It's George, and I'm back again, and I'm here to explain a couple things. So bear with me, and I'm also here to put on a little bit of a rock show. Now this will be incomplete and unfinished meteorites part 2. Okay, let's look at all the facts. Okay, experts say all the metal sank to the center of the earth. Okay, well, if that was the case, then how did the Vikings, Romans, and Egyptians make coins, swords, and armor with no metal? Okay. Now we know earlier civilizations didn't have mining machinery and technology like we do now. Okay. Scientists believe meteor showers brought water and more metals to Earth. So if that is the case, there would have had to have been large-size meteors that hit the Earth directly. Okay, but yet no one has found a whole meteor intact. A burned up fragment or a tiny piece like this couldn't carry water. So, why do people not look for whole meteors, meteorites, and debris fields? Because of the everything burns up in the mesosphere theory. Okay, now personally, a 66-ton Hobart meteorite should be classified as an asteroid because if it was blown off the Earth back into space, it would not be a 66-ton meteorite. This is the problem labeling any size or weight of rocks that are all different, all the same. And why is it no one ever says a meteorite killed the dinosaurs when it says that any rock from space hitting the Earth is a meteorite? Okay, you really got to think about this stuff and the people that teach it to people. Now, I'm going to show you something. Okay, I'm going to show you a rock. And we'll go down here. Okay, this magnet right here signifies the magnetic rocks. Okay, I'm not going to sit here and I'm not going to play with a magnet. Okay, these over here are non-magnetic. Okay, now we're going to go to this one first. Okay, now they have weird, bizarre looking insides and outsides. Okay, but the thing is in the center, and there's no cracks whatsoever. In the center, there are these what I call ice pockets. Because rocks in space are minus 455 degrees, okay, if there was any water inside them, it would be ice, it would be frozen. And that's just common sense. Anyways, so you've got these small ice pockets like this, okay? Well, I had this rock cut several times, and I'm finding the small ice pockets in there. Okay, well, I went to a bigger rock that I had, and I had showed in a video before this. There's a picture of an ice pocket, is what I'm going to call it, because it would hold water if it was thawed out. Water would freeze inside the rock. Anyways, that one's bigger, and that one came from a rock that was about this big around. Okay, now let's say, for instance, you had a rock or a asteroid or a meteor that was several thousand tons. Now you're going to know where I'm going with this when I show you. If your rock is several thousand tons and it's huge, like the size of Texas, okay, those ice pockets are going to be, they're going to be way bigger than what you see right here, okay? Because it's a larger rock. A larger rock means there's going to be bigger ice pockets. Now, what is the theory on that? What is my theory on that? Because I'm all by myself and nobody wants to help and everybody thinks I'm dumb and stupid and crazy. My theory on that is when the molten metal and the minerals go toward the center, they melt down and they start to go towards the center of the meteorite. Or they go towards the center of the meteor, excuse me. when the liquefied minerals and meteors come in contact with those ice pockets, if there's a massive amount of moisture, liquid in there, because it's thawing the ice when it's burning in the mesosphere, then you're going to get a super big explosion from liquid metal hitting what scientists would say they're carrying water. Any kind of coldness on the inside, especially if ice melted and became liquefied, or it was just ice that metal came in contact with, it would cause a severe explosion. And thinking back, I believe that's what caused the 1908 explosion and the one in 2013 over Russia. They had fairly big pockets like this inside the rock. Okay. But like I said, I have to guess this stuff because nobody wants to help. Nobody wants to even think or investigate. Okay. Now, we're going to go to... Okay. Now we're going to go to something else that I looked up. I was hunting, I was looking up, I was trying to figure out, because, you know, sometimes people make mistakes in the stuff they're trying to figure out because they're not an expert. I'm not an expert, okay? But I can put two and two together. Okay. Nickel ferrous serpentine is a group of minerals, okay? These minerals are typically green and brown, okay? Let's keep that in mind as we're going along here. Okay. Already did that rock. Let's go to this one. Okay. This one. Virtually all green on the inside, which is totally bizarre. The outside's like silver, but the inside's green. Oh, okay. We'll go to this one. This was kind of a unique one that got cut open. It's got metal on the outside of it, but it's like a brownish, tannish green on the inside. Okay? Which leads me to believe that this is nickel ferrous serpentine that's on the inside. It's really high in nickel. Okay? Same with this one. Okay? Look at that. Okay? Now, why am I not seeing that on the inside? Why am I seeing this green? Okay? Same here. Okay? That's metal on the outside. And this is what I've been trying to explain to people. You cut it open, it's green. Okay? You can't fake this stuff. Okay? And if it wasn't for me looking at the nickel ferrous serpentine thing, I never would have figured it out. I would have thought it was something else. Anyways, these are all magnet that I'm going to down here. Okay. This is like a brown. Okay. Well, nickel ferrous serpentine is brown and green. Okay, so here we go. Okay. But why the magnetism isn't so tough as it is on some of the other rocks? Because this didn't finish. It didn't finish. And this is the point I'm trying to get across to everybody. You know, you could sit here and you could sit here and you could play with a magnet all day on these things. Okay, now why do some of them pull harder than others? Okay, this is almost like a black. Okay, it cooked longer. It cooked longer. You can look at the outside of it. Okay, it's metal on the outside. And it's also black. And it's rough, okay? It cooked longer. Now, that one was a bizarre one, too. That one was a bizarre one, too. It's a black with what looks like calcium-rich inclusions in it. But like I said, I have to guess on everything. And yet, you see the magnet stick to it, okay? Well, what green metals, brown metals, black metals is, and this is what's driving me nuts in a sense. Okay, now this one is really particular weird because it's got crystals that are lengthwise like this in it. You may not be able to see it in the video, but I can see it under a magnifying glass, and if a microscope, I had to get a microscope, I'd have a better picture of it and be able to show people. But that's kind of got some funky green, weird looking colors in it. And it's magnetic. Okay, well, what kind of metal is that? But the rock looks like this on the outside. It looks green with a bunch of white crystals, but when you cut it open, this is what you get. And like I said, a lot of the crystals aren't like they should be. I've got ones that are that way. They spread out that way. And they're rectangular. Okay. Now, I'm grateful for everybody that's watching, everybody subscribing, and everybody that's, some people that are understanding this and getting this. But eventually, I'm going to come across something when I cut a rock open that somebody out there isn't going to be able to explain. But like I said, I have to be like the experts. I have to guess and assume at stuff because I don't have the knowledge up here that they do. They learned everything. They learned all the terms and everything. I don't have that. I go by what they put out there. I read it, and I try to put everything together the best that I can. But this is a lot of what I'm coming up with. And one other thing that the scientists do not know that I do know, because of those particular types of meteor showers like the one in 1833, the Earth is composed of rocks from other planets, other moons, debris from stars that are in this solar system. Their Earth is made up of all of them. Now, whether people want to believe it or not, this is what a rock looks like from Mars. Whether you want to believe it or not. This is a rock that I cut open, okay? I tried to grind it down. It doesn't look pretty there. But when it was cut open, that's what you come up with. And Mars is green. The scientists have drilled into it and found out that the rocks are green. There's red on top. There's like a red iron coating on top or whatever. But when you drill down in, you get green. And let's look at that again, okay? You aren't going to find another rock like this on Earth unless you're looking for it. You have to know what to look for. Anyways, that'll do it for this video.